So what is software engineering? In a nutshell, it's telling a computer in excruciating detail to do something. But what does this entail? Well, it's a four-step process, starting with problem solving. Firstly, in order to solve our problem, we need to define it. Before we start coding, we need to articulate and understand the problem that we're aiming to solve. This involves identifying the scope, constraints, and desired outcomes. Once the problem is well defined, the next step is to strategize our approach. This involves considering various methods and deciding on the most suitable way to tackle the problem at hand. We need to choose the right algorithms to use. Algorithms are just sets of step-by-step instructions for the computer to follow. We need to define what inputs we expect to receive, whether it's user input, data from an external source, or any other form of input. Understanding the nature and format of this data is crucial to crafting a robust solution. We then need to think about expected outputs. What should our program produce when it's given these inputs? In essence, successful problem solving in software engineering is a meticulous process of understanding, strategizing, and implementing solutions with precision. Once we've determined our approach to tackle the problem at hand, the next steps involve translating our solution into a functional program. This involves translating our logic and solution into a set of instructions that a computer can understand. To do this, we utilize text editors to create the necessary files for the computer to execute our program. These files serve as the blueprint containing the code that we've meticulously crafted. The final step in this phase is typing out the correct syntax for the language's compiler or interpreter. This ensures that our code is properly translated into machine-readable instructions. So what do we actually mean by interpreted and compiled? Well, in a compiled language, the source code that we write is translated into the machine code or an intermediate code by a compiler before it is executed. This compilation process happens prior to running the program. The resulting compiled code is platform-specific and optimized for the target machine, which means that it has performance benefits. Some advantages of these compiled languages include faster execution and the ability to catch errors before the program runs. Some examples of these compiled languages are C, C++, and Rust. On the other hand, interpreted languages do not go through this compilation phase. Instead, an interpreter reads and executes the code line by line at runtime. This flexibility allows for more dynamic and interactive development, as changes can be tested immediately without needing to compile the code first. Python, JavaScript, and Ruby are some examples of interpreted languages. In essence, this process encapsulates the transition from problem solving in our minds to the execution of our solution and code by the computer. The next problem we have is bugs. Bugs are an inevitable part of the coding process, and understanding how to troubleshoot them is a crucial skill. Often, bugs are as simple as a misplaced character or syntax error. These seemingly minor issues can lead to significant problems, so carefully reviewing your code and debugging tools can help identify and rectify these typos. Incorrect usage of the functions of our language is another common source of bugs. Verifying that you've employed the right functions for specific tasks is essential. For example, in JavaScript we have two functions called slice and splice. They sound similar, so they're easily missed and do similar things, but the output is different. Bugs can also stem from inaccuracies in mathematical operations, whether it's a miscalculation or using the wrong formula. For example, maybe you're trying to work out someone's age by subtracting their birth year from the current year. You may end up with an incorrect answer depending on whether they've had their birthday yet. So how do we uncover these bugs? Well, we test. Using your software as an end user is a powerful testing method. You should walk through your user's journey, ensuring that each action yields the expected result. This user-centric approach helps catch issues from a user's perspective. It's important to bear in mind, though, that testing isn't just about confirming what works. It's about understanding where things might break. You should assess different scenarios and inputs to identify weak points in your code. It's important to realise, though, that testing is not a one-time event, but it's an iterative process. As you fix bugs or make updates to your code, you should revisit your testing procedures. This just ensures that new changes don't introduce new issues into your software.